Mitosis, but digestible. Greetings, this is my first video of the Digestible series. Let's begin with something basic and make it simple. The cell cycle, mitosis. The cell is the building block of life. For life to continue, it needs to reproduce. Mitosis is the process where one cell produces two daughter cells, and it is part of the cell cycle, or the different phases the cell goes through. For this process to happen, the cell needs to grow in size, gain nutrients, duplicate its DNA, make more organelles, and later on divide in half. The cell cycle is divided into two, interphase and mitosis. Each has subdivisions. Interphase is where cells spend most of their time. It is divided into G1, S, G2. G's are for growth and S is for synthesis. G1 is where most cells become committed to either continued division or exit from the cell cycle. The exit from the cycle is called G0 or arrested state, where cells don't divide. Examples of these cells are nerve cells and heart muscle cells. In this phase, the G1, cells grow, build proteins, energy reserves, and building blocks for DNA. Also important, there's 46 chromosomes and you cannot see them because they are not condensed. So in the light microscope, you cannot see anything on interface in regarding the chromosomes. S is where DNA duplication happens. The centrosome also duplicates. The centrosome is involved in the scaffolding in which the chromosomes will later migrate and use to divide. The cell now has 92 chromatids because it duplicated its chromosomes. G2. The cell replenishes energy reserves and protein synthesis and the dismantling of the cytoskeleton to provide resources for the mitotic phase. M is where cells divide. It's mitosis, and mitosis is divided into karyokinesis and cytokinesis. Karyokinesis is the nuclear division. The second portion is called cytokinesis, which is the physical separation of the cytoplasmic components into the two daughter cells. When you have the daughter cells, it goes back to 46 chromosomes. The phases of karyokinesis are prophase, prometaphase, metaphase, anaphase, and telophase. Prophase, also called the first phase, in this one, the nucleolus disappears, the membranous organelles fragment, the centrosomes start moving to the periphery, and the chromatids begin to condense, but not fully. You can barely see them on the light microscope. Prometaphase, the first change phase. Nuclear envelope breaks down. Chromosomes condense further and in their middle section develop a protein called kinetochore, which attaches the chromosome to the mitotic spindle. Centrosomes move to opposite sides of the cell. Metaphase. In metaphase, chromosomes achieve maximum condensation, and they are aligned in the equatorial plane. Um, Each sister chromatid is attached to a single microtubule fiber originating from the opposite poles, anaphase, or diaphase. The cohesive proteins keeping sister chromatids together degrade, separating the chromatids and renaming them to chromosomes. Then each chromosome is pulled towards the centrosome that its microtubule attaches to. The cell becomes elongated, oval-shaped. Telophase. The distance phase. Chromosomes reach opposite poles and begin to decondense, relaxing into chromatin. Nuclear envelope and nucleolus reforms. Cytokinesis is a process that starts parallel to mitosis. As you can see, since anaphase, the cell is elongated and it an actin filament ring forms and it starts contracting and contracting and it forms a cleavage furrow. And this cleavage furrow keeps contracting and contracting and eventually achieves cleavage into two halves of the cell. So one cell becomes two. I want to give a shout out to the sources. So the first one I want to mention is this splendid book called The Cell Cycle Principles of Control by David O. Morgan. It's a 300-page book, but it has everything. Even though it's from 2007, I find that it still is very relevant. Um, so you probably didn't see much of those. It probably wasn't very relevant in this specific video because it was very basic. But in the video that in the series that I will make about everything you don't need to know, I will heavily use this book. Um, but because it's from 2007 and it's so long, I had to use a newer source, which is OpenStax. Um, it's shorter, but it's also very, very informative, and they also go into the molecules involved, which is something that I like. Um, so I will link the link below to both of these sources. Now for the credits. Camila Pimentel, which is me. I did the drawings, the editing, the script, the voiceover. My friend Carwin, which is a pseudonym, she did the script clarity. She made sure that everything I said was clear enough for normal people. I want to thank my family and dogs for moral support and um, I'm just starting this channel, so if you're watching this, I'm very, very thankful that you made it to this point. And please give it a like and comment and subscribe, and I will definitely love you. I will definitely, I will name my firstborn after you in The Sims. So, thank you very much for watching this, and I'll see you in the next video.